In the last section, we'll look at combination drugs. In our first example, we're given a physician order for pediazole, 5 milliliters, administered orally every 6 hours for a child weighing 44 pounds. The pediatric drug reference states that pediazole is a combination drug containing erythromycin, 200 milligrams, and sulfadoxine, 600 milligrams in every 5 milliliter oral suspension. The usual dosage for pediazole is 50 milligrams erythromycin and 150 milligrams sulfadoxine per kilogram per day in equally divided doses administered every 6 hours. And we're asked to determine if the order is safe. Since this is a combination, what we'll need to do is actually calculate for both the limits for the erythromycin and sulfadoxine separately. Let's look at the erythromycin first. In our computation, we need to determine if the order is safe. So what we'll define here as our desired unit is the milliliters given per dose. The first thing we'll do for our calculation is to convert the patient weight to kilograms. So our patient is 44 pounds. We can convert, as we usually do, with our conversion of 1 kilogram per 2.2 pounds. Next, we'll need to include the erythromycin standard, which is 50 milligrams per kilogram per day. We're interested in converting this using the given dosage. In this case, what we have is 5 milliliters, which includes 200 milligrams of this particular drug. Part of our conversion too will include the fact that this is administered every 6 hours for a full day. So to include this, what we'll say is that for every 1 day, there's 24 hours. And every 6 hours, we'll include 1 dose. Let's check off some of our units. Here we can see that the pounds will cancel, as well as the kilograms. We also see that the calculation for the day and hours will give us the milliliters per dose. With our computation here, we should get 6.25 milliliters per dose. So the amount of erythromycin in this case does look to be safe. We're going to administer, in this case, only 5 milliliters. So it happens to be under the recommended maximum for erythromycin. Now we need to check the other component of this particular combination. In this instance, we also have the sulfadoxine. And most of this computation remains the same. But let's start by eliminating some of the previous information. One piece of this that will change is, of course, the dosage recommendation. So instead of 50, we now have 150 milligrams. We have, instead of in the solution that is 5 milliliters for 200 milligrams, we now have 600. The rest of our units will remain the same. And as we go through and eliminate those remaining units, what we'll actually find is a very similar computation to before. We can confirm that our units do in fact cancel, leaving us with milliliters per dose. And because of the arrangement of numeric values here, we actually end up with exact same value of 6.25 milliliters per dose for the calculation. So in this case as well, we can confirm that yes, since we're comparing this value to what's given, 5 milliliters per dose, this does happen to be a safe dosage. Example number 2. The pediatric oral surgeon orders Tylenol and codeine suspension 10 milliliters, which includes acetaminophen 120 milligrams with codeine 12 milligrams per 5 milliliters, administered every 4 hours as needed for pain for a child weighing 42 pounds who's just had their teeth repaired. The drug reference states that Tylenol and codeine is a combination drug. And in this case, the safe recommendation is 0.5 to 1 milligrams per kilogram per dose every 4 to 6 hours as needed. We're asked, is the dose volume safe? So in this instance, what we'd like is to consider the maximum dosage. Is the maximum amount that we give going to be safe? In this particular instance, that means we'll be using the recommendation of 1 milligram per kilogram per dose. The volume in this instance is going to be given in terms of milliliters per dose. For our calculation, again, we'll start with the patient weight converted to kilograms. So 42 pounds is multiplied by 1 kilogram for every 2.2 pounds. Then we'll include the particular safe dosage, which is 1 milligram for every kilogram dose. We also have the particulars of our suspension, which in this case tells us that we have 12 milligrams for every 5 milliliters. With this calculation, we can now make our computation. So we'll convert first the patient weight to kilograms, and then make the calculation for the number of milligrams per dose that will be given. Multiplying here by the 5 milliliters per 12 milligram, we can find the maximum here is 8 milliliters per dose for this particular substance. So long as we're not going over this, then we can confirm that the order is safe. However, if we compare a suspension to what is ordered, 10 milliliters exceeds the maximum recommended dosage. So the question of is our dose volume safe, in this case, is no. The order exceeds the maximum.